If you open a fuse box on any car, you will find two things: fuses and relays. And while checking the fuses is a fairly simple task, checking relays is a bit more complicated. First, what is a relay? To put it simply, it is a switch that is controlled electronically, where instead of using a lever to open and close the circuit, we use an electrical signal to do the same thing. But why do we need relays? First, let's take a look at all the switches inside this car. They are all different forms, shapes, and sizes. We see levers, knobs, buttons. Some are bigger, some are smaller, which is much more convenient than having a standard switch for every circuit. But oftentimes, this convenience comes at a price. Unlike this switch, rated to handle up to 35 amps worth of current flowing through it, some of these switches cannot handle high currents like that. And if you're not sure what electric current is, think of it this way. Just like we need enough water flowing across this mill to make it spin, we need enough flow of electric charges to make a bulb, for example, light up. Speaking of bulbs, let's take for example headlights. Headlight bulbs are usually around 60 watts, which means in a 12-volt system, each headlight draws approximately 5 amps worth of current. Considering we have two headlights, we can conclude that 10 amp current would flow through this tiny switch to power up the headlights. That kind of current running through the switch, possibly for hours, could cause overheating and ultimately excessive wear and premature failure of the switch. And that's where relays come into play. Relays are tough switches that can handle high currents like that, and they don't require a lot of current to be turned on. So when we turn on our headlight switch, we send electric signal to the relay. If the relay is working properly, we'll hear it click. That's our relay responding to our command and turning on the headlights. This is how it works. A relay has a coiled up wire inside it. When current flows through this coil, it creates a magnetic field. In other words, our coil turns into a magnet. This magnet pulls in a movable armature, which connects the contacts of the switch, thus closing the circuit. So if we look at our headlight diagram again, when we turn on our headlight switch, we send power to the coil part of the relay. Very little current is needed for the coil to pull in the armature and close the switch that powers the headlights. And this right here forms a relay with 4 points of contact, 2 for the coil and 2 for the switch. On the coil side, we have control circuit, and on the switch side, we have load circuit. Another reason we need relays is because some circuits are controlled by the computer, the engine control module. Take for example the radiator fans. When the computer sees the engine temperature goes above a certain threshold, it will flip that relay switch on to turn on the fans. So how do we test relays? Most of the time, relays will have all the pins numbered, and on the side of the relay there will be a diagram showing what pin is what. Most common configuration includes numbers 85, 86, 87, and 30, where 85 and 86 are for the control circuit and 87 and 30 are for the load circuit. If you can't find the numbers on your relay, here is a tip. Usually the control circuit pins will be parallel to each other on the outside of the relay, and the load circuit pins 30 and 87 will be in between the control pins, perpendicular to each other. If your pins are in the 4 corners of the relay, like this, pins diagonally opposite from each other will usually be connected. One pair is for the control circuit, the other pair is for the load circuit. If you have a 5-pin relay, the 5th pin would be 87A. It is part of the load circuit and it is normally closed, which means pin 30 and 87A are connected when the relay is at rest. When the relay is activated, the switch disconnects pin 30 from 87A and connects it to pin 87. Pins on your relay may be numbered differently, like 1 through 5 right here, but the concept remains the same. So if you're suspecting a bad relay, first thing you can do is perform a click test. Run a couple wires from the battery to the control circuit pins 85 and 86 and see if the relay clicks. Polarity usually doesn't matter, it should click either way. If you don't hear it click, chances are your relay is bad. You can try to confirm that by checking the resistance between these pins. A good working relay will show resistance somewhere between 50 and 200 ohms. If the multimeter continues to show OL, which stands for open line, there is no continuity between the two pins. Your coil wire must be broken somewhere, so the relay is bad. If the resistance is low, you may have a short in the coil, which won't let the coil create magnetic field strong enough to pull in the armature, in which case the relay is also bad and would have to be replaced. If the relay does click, next thing you want to do is make sure the switch between pins 30 and 87 closes. When the relay is at rest, there should be no continuity between pins 30 and 87 because the switch is open. Let's energize the coil and see if it makes a difference. The switch should now be closed and we should see a very low resistance reading. You can also set your multimeter to continuity and listen for it to beep when it sees continuity. So, if you see continuity where you shouldn't, or you don't see continuity where you should, your relay is bad. Now here is a tip. Most of the time, cars will have the same relays for different circuits. So if you're suspecting a relay to be bad, switch it out with another relay like it and see if it fixes your problem. If it doesn't fix the problem, it must not be the relay, in which case you can check the relay circuit to narrow down where the problem is. Check if the relay has power coming in from the control circuit, from the switch or from the computer. Does the relay get good ground? Does it get power for the load circuit? Will that power make it to its final destination? In other words, is there continuity between the pin 87 and your headlight bulb or radiator fan or your AC clutch and so forth? This should be enough for one video. I will be making another video with different problem scenarios showing steps to solving them, so stay tuned. Give this video a thumbs up if it was helpful. Share your experience and feedback in the comments below. Thank you for watching. Good luck and take care.